That is freaking weird.
Did it say there are no GPU threats to show at this point?
It did say that.
Well,
And
that's why we're here.
well, that seems like you're interesting. All right, you guys. This is baffling, but it seems to be doing what you guys thought it would do.
Okay. Well, the good news is we don't want to continue down this path.
How big is N?
10. I mean, dang.
I'm speechless.
Well, now you can go forth and use printf to debug.
Good job. Well, I assume that once you get more than one thread and block, this becomes completely unstable, but it's interesting that it works in the single-threaded case. Just out of curiosity.
So he said it becomes unstable when you add.
He suspects.
Okay. This should not work. Wow.
Um,
What would make it become unstable? It's printfing in every thread and block.
Yeah, there's more than one. We'll find out.
is it thread ID?
Red IDX.
Thread ID X?
Yeah.
And I thought it was like .x or something.
You got?
No, I think
I'm right either.
thread IDX, but I think
It
you
might
have
be
to.
IDX.x.
I think you have to
Well,
calculate it using the. Well, if you have multiple blocks, you have to calculate it. The overall thread index. It might give you a thread index within the block. Do you not use that?
I do. It's just been so long and it's late and I'm tired. I'm whiny. I don't have all the good stuff you guys have. You know.
Bagels.
Right. The bagels. That's it. Let me move up here for a second.
Should put some.
Cheers, a little sweet.
Don't blame me. Don't blame me.
Come on. There you go.
Brown with brown cookies. Really hard to tell them crispy.
Thread IDX.x.
Just don't want to be crispy.
Dude, but they were too soft.
No. No, too soft. Too delicious.
They're too delicious. I'd throw them away. They're all gone now.
It's perfect to get it like 2 minutes like under what
They say.
makes them like actually stay together and just throw it in ice cream. Right on the spot.
Sounds amazing.
But other than that, like it's really hard to eat when it just doesn't eat.
Congeal. Yeah, agreed. Agreed.
Congeal.
You could just like slide a few off the tray, put it in your ice cream, and then cook the rest for the extra 2 minutes.
Slide all of them off your tray into your ice cream.
Or that's just
live
on
like
the
a
porch
king.
for like
Just slide it in 2 weeks.
I know.
just sitting there. The coolest part about our soap opera is that we can interact with it. We can ask questions.
Yeah?
Yeah, it's nuts. Let us know if you have some questions for our soap opera.
All right. I have to binge watch so I know what's going on.
Yeah, you're gonna have to way catch up. We're like 10 seasons in.
Right. Is there a dog involved too?
No. There's a whiteboard that's especially squeaky.
Mm,
I don't have a chalkboard like you. We're not that cool.
well, it's hard to be that cool.
You have a chalkboard at your house or just in your office?
I have, yeah, the kids have one.
Nice. You do math around there.
We do.
Nice.
Working on fractions.
Nice.
It's pretty abstract.
Yeah. I mean, you gotta get it into them early.
Right? Wait, did that just work too? What the hell? It did.
You did what?
Five
1 and
threads.
5, 5 threads in block,
Yeah,
and it printed all 5.
it looks like it, right?
Uh,
0, 1, 2, 3. Oh, you can't see that.
I cannot.
We can imagine how it would look.
You could.
We have the power.
Right.
Hello.
Right? This is my printout, right?
0, 1, 2, 3, 4. Wow, they're even in order. That's impressive.
All right, let's break this. This deserves to be broken. Oops.
Oh no. I bet it's gonna work. Maxing out the block size. Boom.
Shit. What the hell? They're not in order, but
I mean, yeah, no, I was surprised that the first ones were in order. If it's executing them all at the same time, I fully would not expect them to be in order.
that wow. Okay. Well, that happened.
Yep.
You're learning as quickly as we are.
Yeah.
I like it.
Sometimes the coolest things happen by accident. Or intentionally, in your case.
But it might as well be an accident. Our intentions are basically accidents.
Right. All right. So what the
You need help, like, putting these into a class that we can, like, copy the whole class onto the card.
Because these are currently permutation class functions. We're just, instead of keeping them inside a class, we're just passing around the variables, ordering them in.
Right.
Obviously, we could keep doing that. We could just have a collection of functions in which we know to pass the class variables.
Yeah, you already have a class. You just have to put __ device in front of them.
Right.
That's all we have to do?
Yeah, but so then how does the card know what the permutation? How does it know what the permutation class variables are and the fact that this structure is still a permutation? Can I mem copy the permutation to the card? You were talking to us about creating a child class on Thursday. But that sounded scary.
Children are scary, let me tell you.
And then, like, the child had another class inside it, and we just got overwhelmed, you know?
Yeah.
It gets gross, yeah. Let's see if I can open up the other one.
We've done it. We've done it.
Success.
Still falls apart, but honestly, it's good.
Open project. This beard thing, man, this is getting long.
You think yours is long?
For me, man.
Yeah, no, God, this is long for me. As long as mine have ever been. Does it annoy you?
No.
Okay.
I feel myself like I'm always thinking so hard. I'm always pulling on it.
Yeah.
Maybe I need to think less.
I think it helps me think, actually.
Yeah.
Having something to pull, to stroke.
Got plenty of those.
Yeah.
All right.
Where can I obtain one of these cookies?
All right. So I'm looking at your perm class.
Yeah.
Oh man. Oh my god. That's amazing.
That's beautiful. I want to see myself eating.
As one does. Holy crap. There's a lot of stuff in here.
Oh yeah. I know we're gonna have to start getting rid of the vectors, which is gonna be
The hardest part.
yeah, it's gonna be the bulk of what we're doing, I guess. But yeah, I know Coodah is all about C, not C++, and classes are a C++ thing, so it's just led me to a lot of confusion.
So it's not.
What?
You can use classes in Coodah.
Because it's just all about the declaring of host and device, right?
So the weird thing is you can't use, well, there might be a package out there that lets you use vector now, but vector is, you have to do an include up here.
Right.
Include vector. I don't think there's a vector class, Coodah class yet. That's all. You could write one. And then you'd have a vector class.
Well,
Then we can share it with the world for free.
no, not under Cox Auto.
Yeah, it was different. We're not gonna do that anyway.
Share it in the world for a premium price.
Mm-hmm.
So yeah, I'm comfortable getting rid of the vectors and or creating a class, and then making all these host and device functions. Still, what I'm stuck on is the passing of the permutation from the card, from the host to the card, and back.
So one thing you could do is we could play with you could put another private variable.
Right.
Right, you could make a very Boolean that says this is an on-device variable. And then you could make a function
From device. No.
And that would just do the mem copies and
yeah.
get you on your way.
Right, and before you call, well, I don't know if that's necessary either. So really what you'd want to do is if all of these had their Right. So if you did that with every single one of these functions,
Yeah.
and then it would know that if this class is on the device, it has to use those functions. And it'll error if it's not. Right, so you copy this one. This is a simple example, right?
Mhm.
Yeah, done.
And now, so I can now call is derangement on the device
Inside a different kernel.
Right.
inside a different kernel. Yeah, I understand that. I guess. Well, I have to reconstruct the permutation on the device. Like I've got the permutation on the CPU, which includes its ordering variable and in variable. And I have to pass both those variables to the card and then reconstruct? Or can I pass something already constructed?
It's a good question. I think you can send the whole class as long as the class conforms.
Okay. I mean, yeah, that's something we can play with. We can try.
So, like if you get was moved, if you just change this so the device one only uses arrays.
Right.
Then the device version would use the appropriate one. This is kind of weird though, right? You have to deal with your pushbacks.
Right. Actually, that kind of segues well into another question we had. A lot of these functions return variably sized arrays.
Okay.
So we're wondering what the best practice is for dealing with variably sized arrays, both in terms of creating them and then also in terms of passing them around. So one idea we had was that we could pass arrays with the size as the 0th element of the array so that we never have to pass two variables around. What do you think about that?
It's an interesting protocol.
Where'd you get that idea from, Nick?
Just made it up.
So it wasn't from like class or something?
Nope.
Okay.
I mean, that's used in file formats all the time. You get a header, or even network packets and everything. The header is a well-defined size.
Right.
So like this get was moved is going to create an array anywhere from one element to n elements. Yeah, I guess I don't know how we would pass that around.
So the only thing that having the first element be the size is 0 indexing. I guess if you always one index.
Right.
Because otherwise something like this would be the way, right? Or whatever the thing is.
You have like a return argument.
I just feel like it's easier to deal with to just put it in the array. I don't know.
So I
Perhaps
kind of
not.
feel like it's easier to deal with
Like
as
that?
separate variables because
Okay.
it's just more intuitive. But
Yeah, it doesn't really matter.
it doesn't really matter.
Yeah. Unless you think there's one definite better way.
Well, one's more standard. The other one would be just a strict protocol we'd have to stick to. So it's just whatever thing that we want to do. Or you could even do let's see. You could do give me right, and you can have
Oh man. Templates.
right? You can make your own little vector type class right here, right? And then you have
Size and can even do a pushback.
Yeah. Agreed.
Sounds neat.
Do you think this makes more sense than changing everything to arrays? Return. Return. Return size.
run. Punchy.
So when you create an instance of a class, all that's in memory for that class is function prototypes and the variables, or just the class variables, or like how much information is kept in like not device, but like variable memory. I don't know. How when you create an instance of a class, how much memory does it save? What is
So
it?
you have two different types of memory. You have instruction memory and
Right.
just
Data memory.
data. Yeah. So your data memory would be the thing right there, right?
Mhm.
Your instruction memory is pretty negligible. That's your entire program is instruction memory.
Right. So when each time you create an instance of a class, it doesn't create a new like instance of all these functions in memory. They're just one place in instruction memory, and it can access them from wherever.
Well, if it's a template type like this, once you instantiate a class, then you get a copy of that class.
Right. That makes sense because you're instantiating it for a certain type.
Right.
But a class that is more concrete is not that way.
But I would never really worry too much about instruction memory.
Right. I just like if you were to Coodah mem copy like a class onto the card, what would it copy? I guess, is a good way to ask what I'm asking.
So depends on how you created your copy constructor. If you do a Coodah mem copy, you're actually just copying bits starting from an address pointer to the end address pointer, right? And whatever happens to be in that section gets
Right.
copied. So you wouldn't do a mem copy. You would either let the copy constructor do it, which still trying to think what the truly correct answer to how we're going to do this. And when we have a class that can be represented on both, and it's a pretty trivial class as far as the data is concerned, but it's a fair amount of work to get a device copy of the same instruction.
Right.
Which makes me think that just a compiler, a pre-compiler definition is the best way to go.
That puts all the instruction memory on the card?
Well, it creates so instruction memory is copied just in time. Right, so once you call a kernel, like when you called your let me bring this back up. So when you called like is derangement, right?
It's copied then.
The instruction itself is copied to the card because it's homogeneous instructions. So you only get one instruction anyways, right?
Right.
So whatever that line is. Now, that gets a little bit different if it's a device versus a global.
Right.
Because global is just called once from the host. The device does have to be loaded on there. But again, that memory is so trivial.
But it does it at compile time, or like when does it put the device designated functions onto the device?
So they're compiled, and then at runtime they get loaded to the device.
All at once?
No, just in time.
Oh, okay.
Right. So you're going to call this kernel, and it knows that inside that kernel it calls a bunch of device functions, right?
Yeah.
So it's just when you call that global function, it'll load that and whatever of its device functions.
And then when it finishes, it wipes all that and does it again when you call it again? Kind of inefficient.
The compiler might have some hooks there that says keep on the card, or modern hardware may actually just set a dirty bit, and then if it calls the same function again, it just erases the dirty bit instead of copying the memory back, because it's still the same stuff and it hasn't changed. So,
and then if it needs that memory for something else, it just overwrites it.
Right. Yep. If it runs into that space, it knows it can use it. And then when it looks it up, it won't be in that same location. It has to copy it back later.
I like it.
Yeah. But it's most likely the permutation class, you're not going to necessarily copy it explicitly. Would that be correct? Like, I mean, other things are going to use it internally.
You mean like CPU is going to use it? What do you mean other things?
So we're going to use permutation in the like the map class, right?
I don't think anything inside of the TSP map class calls permutation.
But there are helper functions that do.
Definitely.
I mean, we will never explicitly move permutation to the card, but I think that the CPU will. If that's what you're getting at. We don't know what permutations will need to be moving around before we start running.
But is it the CPU's job to figure out which permutations will be run at some point?
That's something we don't know yet, but I think yes. I think that the CPU will at least find the initial permutation.
And then pass it to the card, and the card will find all the.
Yeah, and the card can start. Yeah, yeah. Each will find different neighborhoods. It's kind of. Wait, go ahead.
But that could be just an array, right?
Right.
Yeah.
At least for the bridge portion.
Yeah, definitely. You could just pass the array and then reconstruct on the card if that makes more sense. Or we could have these, like I said earlier, these functions could just be totally separate. We could have the permutation class, but as far as device code goes, just have a list of functions that mirror those in the permutation class, but you don't need to reconstruct a permutation to be able to run them. Right. You already have the ordering, and that's the only permutation variable. It's nice.
So I think the permutation class, the way you have it now, is fine. And I think if we can get a preprocessor define that will put device in front of all of them. Let me back that up. Once you get arrays versus vectors, we should be fine. Okay. The only thing is using it inappropriately, like using a host one when you wanted a device one, or using a device one when you wanted a host one.
So you're not saying duplicate every function within the class manually. You're saying put a like preprocessor like initiative that puts device, that like sets an option to put device in between, like in front of every function or not.
So what we would do is we would compile this class twice. One with that preprocessor device tag on, and one with it not.
Okay. And then you'd call them, like you construct them differently. Like, how would it know?
So when you call a function from inside a global function on the card, it doesn't know of anything that doesn't have device in front of it.
Right.
If you called one that didn't have a device, it would just say this is not device instructions.
Yeah. What about the variables? I guess when you instantiate the class, it'll create one of the device ones if you're on the device.
Yes. So if you're on the device, that class is fine. Like that pointer gets instantiated on the device, and don't worry about it. It's the only thing is if you want to transfer one from host to device.
Yeah.
Or if you use one that was created on the host and you use that same pointer somehow on the device, that would be an error, right? Because they're in different memory spaces.
Yeah, so,
but that would be a runtime error, and those are harder to debug than compile time.
Definitely. If you knew or malloc on the device, it just puts it in the widest scope of device memory. Because there's like shared local and then like
global.
Global, yeah.
It should put it. It will put it in global. Yes.
All right.
You can force it to go into shared, but yeah.
All right. You just
shared is faster. So if you can force it into shared,
right,
that's better. But
right,
more complicated.
Right, and more complicated in setup because it's only accessible by the block.
Right. And you have to know well ahead of time, probably at compile time, how big that shared memory is going to be.
Gotcha.
And it's small, relatively small compared to the rest.
Right. That I would figure.
Right. So permutation class. is mainly a helper class. Would you say that's true?
As opposed to what?
Um,
I mean, yeah, it is a helper class. I just don't know what the alternative is. A not helpful class.
um,
This
Right.
class messes everything up.
a class with no class. Uh, so I'm still envisioning the wider program, and it still comes down to it's a map, right?
Mhm.
We're still looking for some kind of tour inside that map.
Right. And we're just going to be flying through these permutations, altering them, and checking those tour lengths.
So I feel like the permutation is a helper to some kind of map solver.
Yeah.
Like the map itself is that's more of the data class,
Yeah,
right?
it's a holder class, yeah.
Right. But that's the data. Like that the map itself is going to be the lion's share of the bits. And then the permutation class is just doing operations on that and changing it in some crazy way.
Right.
Right.
See, it's kind of yet to be seen how we're going to parallelize this. I'm kind of wondering, like, if we would ever need like thread indexes or block indexes inside these permutation class functions.
Permutation, probably not.
Probably not.
No.
Okay. Because so my only goal right now in the immediate future will be to turn all the vector operations into array operations and make sure they can all run on the card still in this one thread. But that doesn't, just because it can run on the device doesn't mean it's ripe for parallelization. So that is kind of the next step beyond that.
Right. And I think parallelization makes a lot more sense when you're talking about the TSP map class, because that's what does operations on the whole map that has operations in it.
But there's also the
iterates through
idea
the whole
that,
map.
each permutation is going to have a neighborhood of 50 more permutations, and each of those will have a neighborhood of 50 more permutations. So you could follow these trails. Each thread could follow a trail and for a long time and be searching totally different spaces. So that's where I think parallelization is going to come in. But so it won't be inside the functions. It'll be more about where we start and which direction we let it roll down the hill.
Yeah. That's going to be a problem for Coodah. Now that you say that.
Resyncs.
Because you're not spawning like an even number of threads each time. You're like multiplying how many threads you need as you expand out in your solution space.
So think of each thread has to run the same program as all the other threads in your warp. So think of your entire program being unrolled and everyone running that unrolled program at the same time. So if you have a conditional somewhere, and so say the three of us are working on a problem, right? We all have this exact same tools at our disposal. Alex goes off and looks at is derangement. Well, we all have to look at is derangement at that exact same time. And if Alex is looping over 50, but Nick, you've got 10 and I've got 5, we're still waiting for Alex's 50 in that loop.
Always, even if you don't tell it to sync, to thread sync, they all wait.
Well, warp has to each clock tick is the operation for that program, and you can only have one program.
Gotcha.
Right.
What's warp?
Warp is usually 32 threads.
So in my mind, that won't happen too often because the permutations, at least right now in the beginning, should all be the same size. So any operation you have to do will be done on arrays of the same size. And I don't think we even have that many conditionals yet. And if we do, they're very
Minimal.
they're minimal.
One
Like
line.
there's something that is certain to be hit like once every time. Or yeah, I don't know. I don't feel too worried about that yet, but maybe that's naive.
And it's a good thing to know going into it to try and make each instance of each function running at the same time run as evenly as possible. Like in terms of writing it that way. Although
Yeah,
I guess
it's
sometimes
really
you
hard to tell.
can't avoid conditionals.
It's really hard to tell until we start seeing the ways that we can set up this program.
Yeah.
In my mind, if we have as many like different starting solutions as we have threads, let each one do the same exact thing, we'll get a great answer really quickly.
If they're all
Marching along.
if they all follow the same path and give you an answer at the same time. So it's not just that they call the same functions at the same time. Like, what was the function we were just looking at that had the was moved, right? The was moved function. It
Yeah.
returns a variable size array.
Yeah.
And presumably you're going to loop over that new array in some smart manner.
Right.
Well, if each thread comes back with a variable size array, you're all still going to work on whoever came back with the largest size.
And
That
actually,
makes sense.
about it, the way we build neighborhoods more often than not is to count the number of negative indexes in a map that we've transformed. And there can be anywhere from 0 to n squared negative indexes. And that's how the neighborhood is built.
And you will do the worst of all of them.
Right.
Right. So you're not going to find an optimal solution fast because you're always waiting for your lowest common denominator.
Yeah. But even the lowest common denominator done thousands of times
will yield an answer.
will yield a
that's
not
good,
yeah.
really
But we'll
fast.
definitely we'll obviously have to do some load balancing. It kind of remains to be seen. I mean, all this speculation is something that needs to happen, but I also want to be able to focus on the immediate future. And I think that with transforming the vectors to arrays and getting both classes running on the card, at least on one thread, is a noble enough pursuit for the next few days.
Sure.
Know that we don't have anything new from Bruce, and I don't know when we'll get anything new from Bruce. So our job right now is 100% codification besides the SAS stuff that pops up for me. So
Okay.
we'll be reaching out with questions and doing those two things I mentioned. But yeah, it'll come time to start doing test cases on the card, even if they're like baby test cases, probably next week. So something to stew on.
So what you could do is just convert all of your permutation functions into array functions. Because if we're just going to put a preprocessor define in there, that means that the host ones need to be arrays then too.
Yeah.
Right. We're only going to use one function.
Arrays moving forward.
Yeah.
So it'd be good practice.
That might be the first thing, and see how ridiculous it gets.
Yeah, there are a lot of two-dimensional arrays, or right now two-dimensional vectors that I don't know what to do with, but it'll be a learning experience.
So I could, I don't know what the right thing. So I could probably give you my image container class that I use as an example as far as how you linear index large blocks of data that's multidimensional. That might help you.
Yeah, that'd be wonderful.
We won't share it unless people pay us or ask us nicely.
Yeah, it's going to be open source here in a couple months anyways, so it doesn't matter. Yeah, that might help actually. I think I have a. Is it always 2-dimensional? You don't have anything higher dimensional than 2?
Not that I can think of right
I
now.
don't think so. No.
Okay. So you could just make a like a DIMS class or something that takes row column or XY or whatever you want it to be, and then you can do a dot get linear address.
Right. We have functions that do similar things in the serial code right now, but
Oh, okay. Yeah, it's nice just to be able to do a dot operator, you know,
right.
and get where you want. Um, hmm. Maybe what we should do. You guys keep cutting your teeth on this and keep me involved, and maybe sooner rather than later we'll have Bruce kind of sit in a little bit and kind of get the long view.
Yeah, that sounds great. I can talk to Bruce about maybe meeting Friday or Monday. Like
Okay.
by then, be in a good spot.
Sure. Yeah, if you want to make a meeting Friday early morning or probably Monday, either morning or evening, whatever works for you guys.
Yeah, I'll see how fast we're going, but I'd definitely prefer Friday morning.
Agreed.
Okay.
So, yeah, we'll be in touch.
So I think you should keep going kind of the route you're going